Howdy, we're back. This is your fifth video lecture. This might be a slightly long one, so maybe pause and get yourself a drink or some popcorn. I don't know. We're going to do several things in this video lecture, and all of those things have sort of fundamentally to do with the basic building block of quantitative analysis in political science, the data set. So the first thing you're going to do, as usual, is to open up RStudio, not RStudio. I say R, and I usually mean RStudio. As I said in our very first or maybe second video, we're really not going to be using R itself ever, except as sort of an underlay to RStudio. Okay, so here's what we're going to do. I'm going to do this in a script file. So to open a new script, you're going to click this little plus sign with the document, and it goes RScript. Yes, thank you. That should allow you to have on the upper left an untitled RScript. So let's save that. We're going to go File, Save As. I'm in my, you can see from my Finder window that I'm in my PSci 232 directory. So I suggest you save this in your PSci 232 directory. One thing that I've done in the past is to have sort of an ongoing file called practice.r. And inside practice.r, you can erase, you can delete, you can keep things or not. In any case, so every time you write an R script, you're going to end the name of it with a .r. That is how RStudio knows to open the file, knows what to do with the file, is I guess what I mean. Okay, so practice.r, save it inside your PSci 232 folder. I recognize that this looks a little bit different on a PC. I hope and assume that all of you can sort of come to the analogous conclusion about how to do this. All right, so we've saved it. It's still empty, but it has a name now. Okay. The first thing we're going to do is something called a preamble, and we'll talk more about the preamble later, kind of what is it for. But basically, it tells you what's in there and what it does. So I'm going to say the name of it is practice.r. You can see that I'm using comment characters. That hashtag is actually a comment character that tells R not to read that part. R will not read commented lines, and they will show up in green in your RStudio window, helpfully. So we're going to say a place to practice. You can write whatever you want. Notice that if I were to start writing without a hashtag or a comment character, it shows up in black, and R would occasionally try to read that. That's gobbledygook. I'm going to get rid of it. So now that you have a preamble of some sort, you might want to save it. Now we're going to start we're going to load some data. So the first thing I want you to check is that your PSci 232 folder, which is probably on your desktop, contains the data counties.csv. This one. If it doesn't, you should pause the video now and go get counties.csv from the data section of our Blackboard, and just make sure you download it with that name. Cool? Cool. All right, if you needed to pause and do that. Now you're back. We are going to load counties as a data set, right? So .csv is your signal that it's a data set, that it contains lots of observations, each with multiple characteristics. Sure. First, we have to give it a name. I like to refer to data sets by names that are sort of descriptive, but also short enough that they're not going to be annoying to type. So for example, for counties, I might write CMTY. You recognize gets, county gets. Oh, guess what? This isn't going to work. Let's see what happens. county gets read underscore CSV, and then you're going to give it the name of the file. You can see by looking here that we are already in my default directory, which is tilde/desktop/psci232. And we should be able to just start typing, yep, counties.csv. That is the name of the file. We're already in the appropriate directory. And now to make CNTY take all of that data, to read the data into CNTY, I will hit source. Oh, look, error. See, lots of errors all the time. Error in read underscore CSV, counties.csv, could not find function read underscore CSV. Ah, yes, that's because I failed to do the thing that I explicitly told you to do in the previous video, which is at the top of every script, you need to make the tidyverse available. Library, tidyverse, like that. Okay, now I'm going to hit source again and see what happens. I think it worked. You can check that it worked by coming down here. So remembering that this is a script up here in the upper left, and in the lower left is your console window. You can check that it worked in a couple of ways. One is to look over at the environment pane and see, hey, look, I have under data, I have something called CNTY, and I have 3,143 observations of 124 variables. Great, that is a lot of data. The other thing you can do is to just type down here, CNTY. Think to yourself, think back to like when we were assigning the value Amelia to the variable Amelia. What will happen when I hit return? Think, think, think. Okay. Oh God, that's a lot. Let's scroll up. Here's what I've gotten. County. It tells me that it's a Tibble. Now, I hate that cutesy name, but it is kind of important. A Tibble is the tidyverse developer's way of telling us that this is a special version of a table. And I really like Tibbles. They are very easy to work with. Basically, a Tibble is any data set. We could also have read counties.csv into a regular table or a regular data frame. So this is just telling you what it is, it's a Tibble, and how big it is. 3,143, the first number there is by default the number of observations, so that's the number of rows, aka the number of US counties. 124 is the number of variables. And then it gives you kind of a sample. So it says, here's the first 10 rows. So FIPS is what's called the County FIPS code, which is a US Census Bureau thing. Yeah, Census Bureau. Then the state name, Alabama, Alabama, Alabama. Then the county name, state and county codes. And you can see that the state and county codes correspond to the FIPS codes. Great. Then we start with the actual information. So what's the total population? What's the total male population? What's the total female population? What's the total non-Hispanic male population, etc. And then if you scroll down a bit, it tells you what all the variables are. So it's a Tibble that starts like this and then has, looking at the line under line 10, has 3,133 more rows and 114 more variables. So those include Hispanic males, Hispanic females, white males, white females, black males, black females, et cetera, et cetera. The number of, looking at these ones in all caps, the number of violent crimes, the number of property crimes, et cetera, et cetera. What is the percentage of people that have less than a high school diploma in 1970 and in 2015? What are the unemployment rates? So you can see that there's just tons of information here. And while not all of it is self-explanatory, some of it is. So that's nice. Then that's how we do that. So we start, every analysis starts with getting the data somehow. And typically in this class, we will be using a read underscore function. In a couple of cases, we'll be using a kind of fancy read function because we'll be reading from a sort of foreign data source, a data source created by a different stats program. But you don't need to know much more about that now. The thing that I want to tell you at this moment is how to refer to individual columns. Okay? So if, for example, we wanted to think about the total population of each county, just the list of populations, all 3,143 counties worth of population. The variable we're looking for is tot underscore pop, and we can make it a variable. We can say pop, or maybe pops, because it's multiple, is equal to CNTY. You're always going to use a $ to refer to a column. $ tot underscore pop. Now, think for a second about what that's going to be. Is it going to be a new data set? Is it going to be a single value? You know it's not either of those things. It's, in fact, when we pull out a column in this way, we've created a vector. And a vector is a fancy name for a long string of numbers. Nothing too exciting there. Okay, so we're going to source this again. And now we have, if you look over in the environment pane, we have something called pops, which is a numerical vector from 1 to 3,143 that contains all of these populations. What can we do with that? Well, we can, for example, look at the distribution of populations over US counties. And to do that, we would write print. The print function tells that, the print function, oops, yeah, there we go. Print function tells RStudio that it's going to want to show us something either in this window or if we give it a different place somewhere else. And then what we will give to print is what is it that we want to see. And what I would like to see at this moment is a histogram, and we'll talk about what that means in a second, of pops. So that's the function you're looking for is hist, parenthesis, pops. Okay? So let's review. We made the tidyverse available to use in line 5. In line 7, we read all of the data into CNTY, county data set, so that now we can analyze it. In line 9, we pulled out one column, the column of total populations of each county. Now, on line 10, we're going to print a histogram of that column. So hit source. Oh, that's confusing. What just happened? I think what just happened is that the print statement is not what R wanted, right? So we do get the histogram, but we also get all this random crap. So maybe we don't use the print statement. Maybe we just do that. Yep, and there's a histogram. So there's a problem with this histogram, which is that there are a couple of counties. So this is probably Los Angeles County, because New York has like 5 counties that are up here with 1 million people. But the vast majority of US counties have not that many. So what can we do? We can either change the number of breaks in the histogram so that we can see the breakdown within this category. Let's try that. So this is what's called an option in the function, hist. So we're going to say pops is the first argument. What do you want a histogram of? Well, I want a histogram which says, here's how often each value appears. I want that, and I want it to have 100 breaks. That's a lot. It's kind of a silly thing to do, but whatever. Great. So I did that, I hit save, and I hit source. And now you can see slightly more of an actual distribution. So most, like the vast majority of American counties have, something like 100,000 people or less. And but there's a wide distribution. But so you don't need to understand what a histogram is. This is just me talking to you about the way that a script works and how, in particular, I want you to remember we're going to refer to individual columns in a data set. Now, you can also do math with dataset columns. So one thing to notice, I'm going to jump back down here and do CNTY again. One thing to notice is that we don't have, for example, percentage male or percentage female. We have numbers. If I wanted to make a column, a new column that was the percent female, what would I do? Take a minute, think about it, pause if you need to. Okay, we're back. What would I do? Well, I would divide the female population by the total population to get a percentage. And the way that I would tell R to do that, I would create a new column. I would say CNTY, let's call it PCT underscore female. Right? That's a fairly descriptive name. We know what that means. That's a new column. Gets, what's the division problem? It's CNTY tot female over, that's just a division sign, over CNTY $ tot underscore pop. Right? The thing to notice is that R is really smart about this. It knows that, in fact, you're not asking it to do some sort of weird division problem where you divide all of the female populations by, I don't know, it knows what to do. If you give it two vectors of the same length, like, for example, the female population and the total population, if R sees that these are the same length, as typically in a data set they are, right? Because data sets have X number of observations, and most columns have that number of observations. So when R sees that these are the same length, R is going to know, oh, I should do that division one at a time. So the new column is going to be the same length as the other columns, and it's going to calculate for every county what is the relevant number. So what I want to do, I'm going to erase lines 9 and 10. We don't really need those anymore. What I want, having created CNTY $ %female, I'd like to see what the distribution of that number is. So I'm going to make another histogram. And within histogram, you don't have to give something a name, although you can. You can just say PCT underscore female. You see what I did? I've made the new column, and now I'm asking it in the next line to create a histogram. So let's see what happens. Hit source. Hey, there we go. So what is the distribution of percent female? As we might expect, there's a huge number of counties where the percent female is approximately 50%. There are very few counties where the percent female is less than 45% or greater than 55%. In fact, many of those counties are in my home state, North Dakota. They are oil boom counties where single men have gone to work in just vast numbers, hugely inflating the population of males. Anyway, fun fact. So this is it. This is kind of the beginning of manipulating data so that you can do useful analyses. If you'd like to please consider making a histogram or taking the mean of some other variable like the unemployment rate, so on and so forth. But for now, I'm going to end this video and ask you to remember comment characters, always library the packages you need, read_CSV, and the $ as a reference for individual columns in a data set. All right, see you next time.